All right, let's dive right in. On a recent episode of Under the Microscope, the fantastic podcast from the Science Talk, a really big question came up. We had these incredibly powerful quantum computers, so why are they so bad at simulating the fundamental stuff of our universe?
You'd think, right? A quantum computer should be perfect for simulating quantum particles, like electrons. But it turns out there's a huge fundamental problem. It's a deep mismatch between how we build our quantum computers and how electrons actually behave in the real world.
So, here's the mismatch. Qubits, which power our quantum computers, are basically abstract bits of information. But electrons, they're a totally different beast. They're physical particles called fermions, and they have their own set of non-negotiable rules. Trying to force an abstract qubit to act like a real physical electron is, well, it's just incredibly clunky and inefficient. But this is where it gets really cool. On that same podcast, Dr. Antonio Manesco from TU Delft completely flipped the problem on its head. He asked, instead of forcing our computers to imitate electrons, why don't we just build a computer out of something that already behaves like one?
And that's the core of his idea, fermionic quantum computation. It's a whole new approach. Think of it like this. Instead of trying to translate a book into a different language, you just build a computer that speaks the native language of electrons from the get-go. It's way more direct and way more powerful.
Just as Dr. Manesco put it, the goal is to build something that's just more like an electron. And this isn't just a wild idea. His research actually lays out a practical blueprint for how we could make this a reality.
So how would you actually build one of these things? Well, the blueprint is brilliant because it cleverly combines technologies we already have, semiconductors and superconductors.
You start with semiconductors, the same stuff that's in all our electronics, and you pair them with superconductors, these amazing materials where electrons can flow with zero resistance. That combination creates this perfect little environment, almost like a trap, where you can create and control states that act exactly like real electrons.
And you want to know the most exciting part? The actual devices we'd need to build this aren't some far-off dream. To quote Dr. Maniscalco directly, they're kind of ready to measure. The technology is literally within our grasp. So what's the big payoff for doing all this?
Let's be clear. This isn't about making your phone faster. The real goal here is to build a revolutionary new tool for scientists, a tool that could let them solve problems that right now are considered completely impossible, and just massively accelerate the pace of discovery itself.
I mean, just imagine it. We could design life-saving drugs molecule by molecule. We could discover brand new materials for things like perfectly efficient energy grids. We could finally start to crack some of the deepest mysteries in physics. This isn't just a small step forward, it's a giant leap into a whole new era of research.
So, all the pieces are on the table. We have a solid theory, a practical blueprint, and the technology is nearly ready to go. Thanks to the work of pioneers like Dr. Manesco, the question really has changed from if we can do this to when.